welcome to, as I said, what seems to be turning into a series of talks about evolutionary architecture. I'm Chris Howe-Jones. I'm founder and CTO of DevCycle, a software consultancy providing services ranging from interim CTO to provide tech leadership through transition to software architecture and development. We specialize in functional programming and data engineering. I'm also the co-founder of this conference, and I'd like to thank all our sponsors, without whom we literally couldn't do this. Our great speaker lineup, especially those of you who I bullied into talking. The event organizers, Beacon House, especially Kat and Sophie, who've done a huge amount of hard work in the background. And last but not least, my co-founder, Fiona Hobbs, for her tireless work in making a drunken conversation we had over wine almost 5 years ago a reality. So why evolutionary architecture? Because the only constant is change, things change. So because I'm a follower of Rich Hickey, who's the inventor of a language called Clojure, I have to have some etymology in my slides. So I have to have definitions in my slides. So let's start with the definition. What is change? So it's the process of replacing something with something new or different. So I'm not talking about altering something in place. I'm talking about replacing something with something else. And our next definition, what is evolution then? So it's the gradual development of something. So developing something gradually, probably the emphasis there on the word gradual. So why should we evolve? Well, change is the overriding system quality in architecture, in my opinion. If only because our understanding of the problem we're solving evolves over time, and the solution we're implementing changes the problem space. So what about these other things that we think about when we talk about software architecture? For example, performance. Shouldn't we think about performance? Well, yeah, maybe, but only when we prove the need to think about it. And if we've optimized for changeability, we can change things to make them perform better. Security, same thing. Yeah, we should start with a minimum amount, but we should optimize that, and having something that's easily changeable makes that easier. How about governance? Well, governance is an interesting one. Governance, audit, that kind of stuff. That almost comes for free with some of the techniques we should look at for changing. So to support change, we need to defer decisions to the last practical moment, and we need to react quickly. And we're talking about architecture here. So in my opinion, architecture is a social skill as much as it is a technical one. It's about the communication of a vision across a development team or development teams, because those teams are the things that implement the architecture. If they don't understand the vision, they're not going to build the right thing. So looking initially at nature in terms of evolution, what are the key characteristics of evolution? Adaptation. So adaptation of subsequent generations to their environment. And in the case of humans and some other animals, we also have to consider the fact that we may modify the actual environment that we're living in, not just adapt to it. So what are the mechanisms of adaptation? So new generations. Every time we adapt, we don't change the individual per se, but that individual creates a new generation, and that new generation is in some way slightly different from the previous generation, and that difference may be advantageous or may not be. So we have some kind of feedback. The ecosystem in which a species exists gives it some kind of feedback. They either do as well as the previous generation, worse or better than the previous generation. That leads us to the fact that there's room to fail. Now, on an individual basis, failure can mean something quite catastrophic. So obviously an individual might fail in the fact that they don't live very long. But as a species, the species has room to fail. So the adaptations that don't work very well don't survive. The ones that do survive and thrive are the ones that are going to create the next generation. So one of the things that nature sometimes does is has short cycles between generations. So this is one of the reasons why geneticists use fruit flies for their experimentation, because fruit flies breed really quickly. They have short lifespans. So the faster that they can mutate, the faster they can get the next generation out, the quicker the change can happen. Obviously, human beings and elephants tend to adapt more slowly over time. How about the ability to fall back on successful generations? Well, we kind of happens in nature, because if something isn't a particularly successful adaptation, it tends to not thrive in the environment, and the ones that do, obviously, so the previous generation might be better than the next generation then doesn't thrive as well as a copy of the previous generation. Reactive to ecosystems. So as I said, we get species get feedback from the ecosystem in which they are living. So they react to the ecosystem and they react to changes in the ecosystem. And we know from nature at the moment, we know through climate change, for example, that if our ecosystems change very fast, then some species really struggle to adapt to cope with that ecosystem change. But species have an impact on their ecosystem. For example, uncontrolled populations can use up a scarce resource. An introduction of an alien species can disrupt all the other species that exist in that ecosystem. So how do we translate this stuff from nature, the concepts of evolution, into software? So one of the things we can do is separate deployment as a concept from the concept of release. Why would we do that? Well, we'll go into that in more detail, but it's basically so that we can move faster. We can create new generations quickly. We want fast feedback. So we want that feedback in development and in production. So one of the things we talk about recently in software development is left shifting our environments so that our development environments is close to our production environments in form and shape and behavior as they can be, so that we get that feedback much quicker. How about appropriate feedback? So one of the things we need to do is capture metrics for anything we think is architecturally important. And we also need a responsive culture. So it's all great getting all this feedback, but we need to be able to respond to that feedback and do something. So while I'm talking about change, why would I suddenly start talking about constraints? Because constraint sounds like the opposite of change. Well, in the past, our industries tried to constrain the concept of change by introducing things like change control boards, those kinds of things. But denying that change occurs and that we ourselves are instigators of change is just burying our heads in the sand. Constraints are important to embracing change, but you need the right constraints. That's because constraints direct behavior. So as examples, we've all heard of Conway's law. We tend to develop software that follows the communication patterns of the organization that develops that software. Inverse Conway's law is a big thing at the moment, or has been for the last 10 years, in the fact that if you reorganize your lines of communication in your organization to match the architecture you'd like, you tend to build software that matches the architecture you prefer. Domain-driven development, we talk about constraints there. So we talk about bounded context. We constrain the context so that we can use the same concept, same nouns, for instance, might mean different things in different contexts. We talk about constraints in terms of work in progress limits, in Kanban, and in kind of flow and lean stuff where we're trying to reduce waste. We might want to use immutability to constrain how our state changes in our running system, so that we can reason about it better when we want to make fast changes. We think about how we control state. We might, in the way we control state in object-oriented programming, is we kind of we encapsulate it. We close on it. We try and constrain change and like constrain the boundaries and the effects of that change. In functional programming, we do a completely different thing. We try to completely ignore change. We kind of sidestep it altogether. What we actually do is push it right to the edges of the system, and we do everything in the middle without any state, just by passing immutable data from one function to another. So the other thing we would talk about is materials. Building materials actually matter. So if we build a house out of modern straw, we're going to get a different house from if we built it out of brick, which we would get a different house if we build it out of concrete. They behave in different ways. Building materials in software really matter. Okay, we can use lots of languages that Turing complete, but the language we use affects what our code looks like at the end of the day and how easy it is to change. So one of the things I like people to think about is the typing of the language. So I prefer to favor what we call structural typing over nominal typing. So what does that mean? What it kind of boils down to is I favor parsing data out before you validate it. So kind of passing data around as a value and then parsing out of that value only the things that you need. We might also talk about weak and strong typing. So not to be confused with static and dynamic. I would suggest that strongly typed languages tend to be better constraint to pick for changeability. So a dynamic weak type language would be, unfortunately, something like JavaScript or PHP. A strongly typed static language might be Haskell, Java, C#. But you can get dynamic strong type languages like Clojure, like Elixir. Those are strongly Ruby, Python. They're all strong but dynamic type languages. Languages with good type inference. That cuts down the amount of verbosity that we have in our language, so it makes things easier to change. I've already mentioned functional programming. I'm a big functional programming advocate. Read eval print loops or other forms of high-speed feedback. So the faster we can get feedback, the faster we can adapt. We can respond to our ecosystem and adapt our software and make changes. Mutability I mentioned on the previous slide. Again, it constrains the way we think about state and what state changes can occur under what situation. So in a highly concurrent environment, immutability is a great property to have. Whether we use libraries or frameworks to build our software. So very quickly, there's quite the difference between library and framework I kind of think of as a tree. So in a framework, you've kind of picked the framework and said, here's what the tree shape's going to look like. Here's the trunk and here's the branches, and I'm just going to write the leaves. Yeah. With libraries, what you actually say is, I've got a whole bunch of leaves, and I am going to construct the tree and the branches so that I can make my tree any shape I like. So the obvious trade-off there is that although I can shape my tree any way I want, it's harder work because I have to do a lot of heavy lifting and gluing all these leaves together. Whereas with a framework, if that fits perfectly the shape of the tree I want, the problem that I'm trying to solve, great, use a framework. Versioning. So versioning of APIs is, I have quite controversial opinion about this. So I would suggest don't, right? Just don't version APIs. What you should try and aim to do is what I call API accretion. So every time that you make a change to an API that's anything other than a kind of what we would typically think of as a patch, I would suggest that what you're actually doing is creating a new concept, and therefore you should give it a new name. So that might mean adding a new endpoint to a REST API. That might mean adding a new data type that gets returned from a REST API. That might mean adding a new field that's maybe similar to the old field, but a different name. So you might have the old field was called full name, and now we've got two fields that are called first name and last name. How about tooling? So one of the things in materials is that we want to do things fast. We want to create lots and lots of generations, react to our ecosystem. So what tooling can we use to help us do that? Well, continuous integration, continuous deployment pipelines, editors that do refactoring and linting, concepts like dark deployments. So deploying some software switched off and dark, but maybe piping the data through it if it's back office. Canary deployments. So deploying something, only routing a certain percentage of our traffic through to it. How about blue-green deployments, obviously to cope with to cope with switching across from one variant, one generation of our software, one version of our software to the next version of our software. Automated testing, alerting and monitoring. So if you listen to Shaitan's talk just before this one, you'll have heard that RVU, who I did a bit of work with, rely an awful lot on monitoring their software in the live environment rather than heavily testing it beforehand. Team structure matters, keeping it small, multidisciplined, keeping DevOps in there. Organizational structure, so thinking about software development as a core function, not a support function. Platform and product thinking rather than project thinking. And thinking about things as entire systems. All of these things make it easier to think about a changeable system. Materials matter because constraints direct behavior. So how do we separate release from deployment? We can discover what our deployment units are using things like domain-driven design, the context and the aggregates. Sam talked about that this morning. We could use event storming to discover what our deployment units are. In terms of introducing, separating the release from deployment, we can use feature toggling. So we can implement something, but deploy it with the feature turned off. We can use branch by abstraction, which means sticking an API in front of something and changing it behind that API unbeknownst to the user of the API. We can look at immutable servers and containerization because they help us to encapsulate the concept of deployment. And also schemas on read databases, what typically people used to call schemaless databases. So things like document databases and key value stores where you apply the schema when you read it. And then obviously you can change your code to make it conform to a different schema quite quickly in the future. So how do we get feedback? We can use, I'm a great advocate of data or hypothesis-driven development. So I'm going to talk about that very quickly. So I like to split up software and map software to ecosystems. So as you see in this diagram, the smaller ecosystems, the inner ones, are affected by the larger outer ones. But the inner ecosystems cause an impact on the larger ecosystems. Also, it's worth thinking about the feedback timescales that differ between the two. So, for example, in the micro ecosystem, in the software environment, the feedback's in nanoseconds, milliseconds, seconds. In the team or product environment, it's hourly, daily, weekly, because it's things like stand-ups and retros. In the biome or the organization department environment, it's weekly and monthly that you get feedback. In the biosphere, which is the worldwide or the market environment, it tends to be quarterly, biannually, and annually. So what kind of feedback should we be looking at? So we can look at some of these things. Some of these things are runtime things. Some of these things are things to do with the product and the team. So automate developer level testing, design feedback in the form of test-driven development, behavioral-driven development, REPL-based development gives us quick feedback, which I mentioned earlier, code reviews for PRs, architectural diagrams and documents, architectural decision records. But on the runtime side, we have a whole bunch of other things, aggregated logs, automated exception escalation, metrics dashboards, automated alerting, escalation, that kind of stuff. So when we're talking about the team or product environment, what kinds of things are we talking about there? So in terms of the team, workflow visualizations, Kanban and Scrum boards, cycle and lead times, stand-ups, show and tells, retrospectives, pastoral care, things like career progression. So encouraging people to contribute to the team and the organization rather than just stand out as a rock star. There are also product level metrics in here, like unique visitors, dwell time, conversion rate, average order rate, bounce rate, mean time to failure, mean time between failure, mean time to repair, mean time to defect. All of those are useful metrics. So when we're talking about organization department level, we might be rolling some of these things up. So rolled up workflow visualizations, so Scrum of Scrum boards, that kind of stuff. roll-up cycle and lead times across the teams, averaged out, not focusing on any individual team. Rolled-up retrospectives and stand-ups, things that are common, that might be organizational things that have come out of lots of those retros and stand-ups. Metrics at department and organization level might be customer retention, net promoter scores, churn rate, customer satisfaction surveys, that kind of stuff. And at the kind of worldwide market level, we're talking about market surveys, profit and loss accounts, consumer surveys, competition analysis, market position, where our failure rates fit in with our competitors, that kind of stuff. So I've covered an awful lot very, very fast there, but the takeaways are separate release from deployment. There's a bunch of ways of doing that. So DDD is great for discovery, event storming, feature toggling, branch by abstraction, continuous integration, continuous deployment, immutable servers, and containerization. And schema on read, dark, canary, blue-green deployments, that kind of stuff, and schema on read databases at the end. In terms of providing fast feedback and reacting to it, automated testing is great. Continuous integration and continuous deployment, again, because faster we release, the faster we get back some response from our user community. Automated observability, the things that Xiaoshen was talking about, alerting, logging, monitoring, all those metrics I just talked about should be baked into the product. When you release something, you should be thinking, well, what do I expect this to improve and how do I measure that improvement? Make sure that mechanism to measure it built into what you're releasing. Metrics at all levels. The problem with putting metrics at one specific level is you focus only on one thing. Visualization of workflows, retrospectives. Culturally, pick your constraints. Materials really matter. The language you use to develop your software matters. Stay small for as long as possible. Recognize that software is core to most organizations. It's not a peripheral thing. Almost all organizations now directly contact their customer base through their software. So software used to be something that a separate department did, but now it's core. Defer our design decisions for as long as possible. Simplify, keep things simple. That's not the same as easy. Writing something very simple is much harder than writing something complex. Architecture, social and a group process. And that is the end of my slides. I've overrun by 2 minutes. So no time for questions. If you have got any questions, ping me afterwards. But thank you very much.